Okay, we're going to look at implicit differentiation, but we're going to throw a wrench in with product and quotient. So brace yourselves and write small because these problems get crazy. Okay, so let's look at this. X squared plus xy plus y squared equals 10. Okay, so do you remember when we started talking about implicit and I was like, X and Y are intertwined and you can't separate them? And you were kind of like, yeah, maybe, but I probably could. Well, yeah, okay, now go try that because this is crazy. Okay, so here's the product law here. Do you see it? It's sitting right here. That X and that Y are multiplying. And therefore, your X is your F and your Y is your G. So that's fun. Okay, so that's what we're going to do. We're just going to put some product law in. It's going to be fine. The rules of implicit still apply. So the derivative of x squared is, in fact, 2x. Now, we're going to add. And within this, we are going to put some product law in here. So we're going to go GFFG, right? We're going to go G, F, F, G, and we're going to take the derivative of F here and the derivative of G here. Okay, so G is Y, and the derivative of X is, well, 1, plus F, which is X, and the derivative of G, which is, 1, but when you take the derivative of Y, you need to multiply by dy dx. Okay, keep moving. Now we've done our x squared, it's 2x. The derivative of x times y is this train wreck. Now we need the derivative of y squared, which is 2y dy dx, right? Equals the derivative of 10, which is 0. Okay, so now let's clean this mess up because OMG. All right, so 2x plus y, right? Y plus 1 is y. X times 1 times dy dx is just x dy dx plus 2y dy dx equals 0. So we're going to do what we do best. We're going to move this 2x and this y to the other side. So that leaves us isolating our dy dx, right? We want to isolate these guys so we can then factor them out. So that's going to leave me, x dy dx plus 2y dy dx equals negative 2x minus y. Now I'm going to factor out my dy dx. dy dx factored out leaves me x plus 2y equals negative 2x minus y. I'm going to take this party up here, and we're going to divide out the x plus 2y, right? We're going to divide that away and leave dy dx. So that's going to leave me dy dx equals negative 2x minus y divided by x plus 2y. And that, my friends, is your answer. Okay, so really nothing's changed other than the fact that we were very careful to drop in some product rule in the middle of this. Now, these can get a little bit rowdy. So, should we do a crazy one? Let's do one. Why not? All right. 3x plus y cubed minus xy equals x squared plus y to the 5th minus 13x to the 10th. I mean, it's crazy. But here is our product law, okay? But, oh, there's a negative there, so we're going to need to be real careful of that. Okay, let's go. So the derivative of 3x is 3. The derivative of y cubed is 3y squared dy dx. Now, I'm going to go ahead and put my little subtract guy here, and then I'm going to put some giant brackets to make my product for my x and my y, right? So that's like saying I'm going to just deal with a positive x and y. So again, if this is my f and this is my g, I'm going to go g, f, f, g. So g is y. The derivative of x is 1. So, I mean, I'll write that down for you. Plus g, f, f is x. G, the derivative of y, is 1 dy dx. Okay? Equals, the derivative of x squared is 2x. The derivative of y to the 5th is 5y to the 4th dy dx. Minus the derivative of 13x to the 10th is 130x to the 9th. Oh, brother. Okay, let's real quick clean this up. So I'm going to really just kind of rewrite this beginning part. And then here, I'm going to not write these ones. I'm going to do my multiplying here, and I'm going to distribute this negative. So that's going to leave me minus y minus x dy dx equals 2x plus 5y to the 4th dy dx minus 130x to the 9th. Okay, same deal, but there's a secret extra step here. So we need to get, let's make these blue. We need to get all of our dy dx's together. And they're not on the same side right now. So we need to put them on the same side. So I need to get all the blue on the same side and everything else to the other side. So to do that, I'm going to put all my dy dx's on the left side. So 3y squared dy dx minus x dy dx. Now I'm going to take this guy and I'm going to subtract him over here. So minus 5y to the 4th dy dx. Okay, that's all my blue. Equals, I've got a 2x, I've got 130x to the 9th. Now I need to I'm going to subtract over the 3, add the y, and I should be good. Minus 3 plus y. Same deal. We're going to go through and we are going to factor out these dy dx's. So I'm going to factor out my dy dx. It's going to leave me 3y squared minus x minus 5y to the 4th equals 2x minus 130x to the 9th minus 3 plus y. Divide it, and we're done. Dy dx equals 2x. Okay, let's write this in descending order. Negative 130x to the 9th. Good gracious. Plus 2x plus y minus 3 divided by, I'm going to put this in descending order too, negative 5y to the 4th plus 3y squared minus x. And that is a total and utter circus that's completely accurate and correct. Cool, huh? Okay, and let's try one with quotient law. So what if we have y cubed plus x squared divided by y equals 8. All right, so here's our quotient law right here. And this is going to be our f. And down here is going to be our g. Okay? And remember, quotient is g, f, g divided by g squared. Okay, so y cubed is 3y squared dy dx plus quotient law. G is y. F prime is 2x minus f, x squared. G prime is 1 dy dx divided by g squared, which is y squared, equals 0. Really, sometimes I don't really know why I do this to us, but okay, here we are. So, what are we going to do about this? Well, first of all, we're going to clean it up, and we're going to get 3y squared dy dx plus 2xy minus x squared dy dx over y squared equals 0. Now, we really need to get this y squared out of here. So we're going to multiply everything by y squared, right? So if I multiply this by y squared, and this by y squared, and this by y squared, what happens? I'm going to get 3y to the 4th dy dx plus 2xy minus x squared dy dx, right? Because these canceled, still equals 0. Okay, so this is significantly better. Okay, now we need to do what we've been doing, and we're going to get rid of everything that doesn't have a dy dx. So that means I'm going to keep the dy dx's on the left side, and I'm going to move my 2xy to the other side. Move this party up here, factor out my dy dx, and we're, not an equal sign there. And we're going to be left with 3y to the 4th minus x squared equals negative 2xy. Divided out, dy dx equals negative 2xy over 3y to the 4th minus x squared. And you're done. Now, that's it. Okay, so there's one other thing we need to talk about. Implicit plays by its own rules. So if you're online or on a calculator, like an online calculator, or on Desmos, you have to push a button that says implicit. It doesn't calculate normally. There's an extra button that you always have to activate or push or do something. So if we go online, have you guys been to the derivative calculator? All right. So if you go online, there's a derivative calculator that you can use, and I think you'll find really useful because you can double check your work, and it'll also show you steps. And if you use the derivative, if you use a derivative calculator, you kind of have to learn how to speak its language, but you can put any derivative right in here, and it'll show you the steps. Like if we want to find Like if we want to find the derivative of something, you can. So, but I want this to open. In derivative calculator, you can't just put the derivative in here. You have to come over here under options, and it's not letting me click in there live right now, but if you go under options, it'll ask if you're doing implicit, and you have to check the implicit box. And then it will use implicit differentiation on your function. But you have to very specifically tell any online platform that you're using implicit. So that's something that can trip people up. So if you ever find yourself doing that, just as an FYI. Okay, that's it. Have a good one.